next work is abstraction-based controller synthesis, motivated by safety-critical control of dynamic systems. In this approach, we start with a system model, for example, an ODE with control inputs, and a specification, for example, linear topologic formula. The goal is to construct a discrete abstraction that can be used for controller synthesis. This work answers a theoretical question related to this approach, which is, when can an abstraction-based procedure find a controller if such a controller exists? The main result shows that under mild technical assumptions, one can always construct a finite abstraction of a perturbed dynamic system, while this abstraction itself is abstracted by the same system affected by a slightly larger perturbation. The consequence of this work is that we can achieve the following decision diagram through what we call a robustly complete synthesis algorithm. Given an ODE model, a temporal logic specification, and any parameters delta 1 and delta 2, where delta 2 is strictly greater than delta 1, but they can be arbitrarily close, one can compute a finite transition system T such that T abstracts S delta 1 and S delta 2 abstracts T. Then we can use this finite transition system T to determine whether the synthesis problem is realizable for T. If it is realizable for T, then we have found a robust controller for S delta 1. If it is not realizable for T, then we also know that the same specification is not realizable for S delta 2. In other words, we can achieve so-called delta completeness for nonlinear controller synthesis.
Hello, everyone. I'm here to present my talk, Formal Abstraction and Synthesis of Parametric Stochastic Processes, which will be on the 25th of August. We will present how to formally verify uncertain models, especially in the form of parametric and written in SDE, stochastic difference equation form. We noticed that parametric models, especially in the verification community, are typically written as Markov models, either a Markov chain or a Markov decision process. But what if we have parameters in the stochastic difference equation? Well, we will present our answer, which is parametric formal abstractions. A few takeaway points out of the talk. We will have the extension of the formal abstraction technique towards parametric models, and we will do so by an analytic inversion of the kernel, or we will have to approximate the stochastic kernel. Finally, we will have a real application, which will be a population of solar panels embedded into the electricity grid. Hope to see you numerous. Bye. See you the 25th.